Okay, let's look at the homework 5.3, problem number 7. Alright, so if you look at this differential equation here, this looks familiar, right? Actually, including that one, so initial condition. Alright, so this is the limited growth model. So limited, oh, actually, I can't spell. Right, limited growth model, right? So the solution n of t is going to look like this. N of t is equal to, right? So capacity in this case is L times quantity 1 minus e to the negative kt. All right. So since let's see, L is not given, but K we can figure out from this condition here. All right, so let's find that. So it says that n of 14 is equal to L times 1 minus e to the negative, so K times 14, so 14K. Right, and this is equal to 0.5 L. Alright, so we can find the K by dividing through by L. Alright, so you have a 1 minus e to the negative 14K is equal to 0.5. Alright, then I'm going to just subtract 1 from both sides. I'm going to go here. Alright, so you have negative e to the negative 14K is equal to, right, 0.5 minus 1 is negative 0.5. Alright, then I'm going to go ahead and multiply by negative 1 so that we can turn this into a positive sign here. Alright, then we can take the natural log of both sides. So take the natural log. Then you have e to the negative 14K is equal to natural log of 0.5. Alright, then you can see that we have natural log and exponential functions are composed together. So since they are inverses of each other, they cancel each other out. Alright, then we just have negative 14K equals to that, so we can divide through by negative 14 to find K. Alright, so K is going to be natural log of 0.5 divided by negative 14. Alright, so let's find this value. Let's see. Round all decimal values to the nearest to thousands as needed. Alright, let's do that. Alright, so here is Geogebra. So I'm going to just type in natural log of 0.5 and divided by negative 14. Right? Then we want see the thousands. So I'm going to see 3 decimal places. Alright? Then hit enter. Right? Or actually, maybe I didn't change it. 3 decimal places. Right? So it came out to be 0.05. Okay. Alright, so let's type it in. So we have, so it's going to be 0.050. Something like that. Alright, so we're going to have here, we're going to have L times 1 minus e to the K, it's 0.05 times t. Right? Oh, actually, I forgot the negative sign. Right? So we have that. Right? Let's check the answer. Right? We got that. Right? So what percent of L will have been exposed after 2 days of campaign? Right? So let's say after 2 days. Right? So we're going to plug in, so L is in days. So we look at the n of 2, right? So we just plug in L times 1 minus e to the negative 0.05, then you multiply by 2, right? T is 2, right? So we get L times 1 minus e to the negative 0.1, right? So let's find this value. Let's see what's the precision they want. Right, so nearest the 10th as needed. Okay, all right. Oops, that's not. Oops. Right. So let's look at that. Right. So we need to compute using Geogebra. Let's see, 1 minus e to the negative 0.1. Right. So it came out to be, let's see, L actually. Then we have to turn it into a percentage. So we have to multiply by, so B times 100, oops, times 100 to turn it into percentage. Right, so it's going to be at 9.5. So let's type it in. So this is going to be about 0.095. So it's about 9.5%. So this is 9.5%. Right, so let's type it in. So we have 9.5. Right, check the answer. Right, so we got that. Right, part C. How many days will it take to expose 75% of L? Right, so let's do that. Right, so we just need to set this guy, which is L times 1 minus e to the negative 0.05 t, and we want to set this equal to 0.75 times L. Right, and as usual, we can divide through by L, so you can cancel those out, and then try to solve for t. Right, so let's subtract 1, so you have e to the negative 0.05 t is equal to, right, subtract 1, so it's going to be negative 0.25. Right, then multiply both sides by negative 1. I'm going to go ahead and do that, turn it into positive. Right, then we can take the natural log of both sides. Right, if you take natural log this side, so I'm going to go ahead and cancel, so you get the negative 0.05 t is equal to natural log of 0.25. Right, then in order to find t, we can just divide through by negative 0.05. So t is going to be equal to natural log of 0.25 divided by 0.05. Right, so let's find this value, and let's see what's the precision. Round to the nearest whole number, so let's do that. Right, took Geogebra, and natural log of 0.25, and we want to divide it by negative 0.05, right? So it came out to be 27.7, so it's going to be 28. So about 28, let's type it in. It's going to take about 28 days. Like that. Right, we got this one correctly. Right. Then graph the solution in part A for t is between 0 and 90. Alright, so L value is given at, it looks like it's 100. And you can see that L is the limited capacity, so eventually it's going to head toward L. So it looks like this is away from L, this is away from L. This is the only reasonable one, so this is going to be it. Alright, check the answer. Alright, that's it. I hope that this was clear.